yet another stream. Um, got an exciting one for you this week.
There's something going on over here.
Yeah, there's something obstructing part of Steven's shoulder right now, and that thing is what we'll be talking about this week.
Yeah. Those with a keen eye might know what this is already, but
That's true.
it's hard to tell based on just one small piece of it.
But also, I realized based on the YouTube thumbnail and title of the stream, they would know what it is.
That might give a hint. Yeah,
Right.
that's true.
Right. Right. So, as we wait for people to come in, welcome to anyone new. We're going to be talking about automation on large printers today and celebrating the start of the CR-10 beta program, which we already have a bunch of people signed up for, waiting for their beta kits, and we'll be showing off the beta kit here very quickly. Whoa. And yeah, we'll also be talking about the implications of, automating larger machines, because this is the first time that we've looked at automation for large machines. We're talking about the CR-10 today, but we're also beta. We've got the Sidewinders in beta as well, and they're the exact same size. So just going to be exploring that a bit today. And yeah, talking about what it means to automate these types of systems, and also what the beta program for these are going to look like.
Yeah. So this is the largest printer that we've automated so far, and it's pretty cool what the kind of new things you can do with such a big printer. I think it opens the door for a few new industries to pop in and check out our automation. So if you need to print big stuff, stay tuned because we've got some stuff for you.
Yeah, and anyone, I already see in chat John Beatty and Justin 3D. Welcome back.
I know Justin has some CR-10s.
Yeah. Is he in the beta program?
I think he will be.
Okay, cool.
We'll see.
We got Asha in chat too.
There's Asha.
Yeah, so anyone watching, if you have any questions or anything, make sure you sign into your YouTube account, and yeah, just post in chat. We'll be watching chat. Justin's hitting us with the questions. Uh-oh. John, I saw your email, and I have some news for you, potentially.
Yeah, it turns out Ender 3 Max is very similar to both CR-10 and Ender 3, so it's looking promising, but we'll have to address it when it comes.
Yeah.
So
I have some news on that though.
Okay.
Tomorrow will be for Sidewinder. Tomorrow will be for Sidewinder. Okay, before we jump in, actually, we should introduce ourselves. Anyone that's just joining us for the first time, I'm Mateo Pekic. I'm one of the co-founders of 3DQ. I did all the initial tinkering on 3D printer automation years ago, and now I mainly focus on the Quinly software. And as you know, last week we did a big UI release, so Quinly users who haven't upgraded, I would suggest you do, because it is far nicer to use. So far the feedback's been very positive. And of course I'm joined by Steven.
Yes, I'm the Quinly product lead, so I do all things Quinly, designing parts, printing them, getting them shipped out, troubleshooting, firmware, bit of everything.
Working with the engineering interns to help design everything too.
Yeah. It's a bit of fun.
Yeah. Audio's a bit low. Okay.
Boost the mic maybe. And
yeah. Thanks for catching that, Ben.
I'll grab it. Try to close the door.
Good to get this all out of the way at the beginning of the stream.
Yep.
And then in a second here, we'll show you the CR-10, and we'll start talking about what it means to have a large-scale automated print farm.
Yeah, thanks for telling us about the audio. Some people have told us before that audio is too low. For us, it sounds fine, but then for you guys, it can be different.
I think this...
Put it up to like 6 decibels or something.
6?
Yeah.
Awesome.
Try that. How are we sounding now? That should be better.
I think that's better. I can see
the bar is getting bigger.
Yeah.
Cool.
Awesome. Yeah, let's get into it. So we have with us here our special guest this week, the CR-10.
Whoa,
Wow.
look at that.
It's a pretty familiar form factor, tilted at an angle, got a vapor bed on the front, and it's got some internal ramps that prevent your parts from getting trapped. I'm going to show them.
Should I take one out? Yeah, this is actually our largest printed part to date. So these guys, these are huge. They take up a full like Ender 3 build height. And I get the whole thing in the shot. Actually, I'll get up my main camera. You know, these things are big. So they're actually printed like vertically here. And they're just printed like that on a vapor bed. And yeah, they actually work.
Yeah.
They're definitely like a weird shape for 3D printing since they're so tall and skinny, but they do end up printing out quite well. Check out those layers. Can we get the light? Yeah, it's pretty good.
Grabbing some earplugs now. Okay, I guess our audio is better now.
There. It's easier to turn your volume down than it is to turn it up.
Yeah, that's true. Yeah, and actually something we kind of discovered designing this kit and doing big parts is that, you know, we're now hitting the limits of the build volume of our Ender 3 farm. And so even for us, the CR-10's been super highly requested, but even for us now, ever since we got it in and started using it, I think everyone's kind of been brainstorming ideas of actually how like big 3D prints could help produce different kits. For example, on our Ultimaker kit, a lot of the pieces we've had to split into 2 so that they would fit on the Ender build plate. But with the CR-10, we wouldn't really have to do that anymore. And it actually ends up saving, like it's a form of part consolidation where you end up saving money in the sense that you don't have to do as much assembly afterwards.
Yeah, so there's actually, in the Ultimaker kit, there's 8 parts that could in fact be 4 parts if we printed it on a CR-10. And so what'll likely happen is once we get this CR-10 into production, we'll start printing our Ultimaker parts on it and turning our part number from 8 to 4.
For those parts.
Just for those parts. Yeah, there's like 24 parts.
Yeah.
25 parts.
And it's going to be interesting now. So up until now, our you know, our print farm has been exclusively Enders. So now that we have have like a mix, or as close to a mix as is like reasonable, you know, it's barely a mix, but we have a bigger printer now. It's going to be interesting looking at how that affects production workloads, because back when we were designing the enterprise software, there was the option to like send print jobs based on the type of printer, like match it to the printer based on how big or certain properties of the print jobs. And now that we have one of these machines, you know, a year later, it's kind of got us thinking again, like, okay, how do you, if you have a mixed farm, which a lot of people do, you know, how do you optimize production for that? Obviously, parts that are too big for an Ender are going to go on the CR-10, but what about in other cases? Does it make sense to combine certain parts, have them print on the CR-10, or like how do you distribute the workload? So that's something we're thinking about now. When we're looking at the kind of pro and farm management version of the software, actually matching it your file to the most appropriate printer.
Yeah, and it's nice actually having a print farm of 20 something enders is nice. But now that we have this larger printer, it'll let us start to kind of expand our efficiency just by consolidating parts. And before we've been sort of we've been saying that it's actually best to keep everything the same, keep all the printers the same, and that's like kind of what we're doing. We have 25 or whatever of the same printer, and now we have one big printer. We might get a few big printers, just to fill in the gaps where it really does make sense to have a few printers. So
Yeah,
it's not good to have like 6 different printers, but 2, that's reasonable.
And
as long as they're different.
It's definitely one of those things where you like until you start using a larger print area, you wouldn't really know. Like you don't really see that sometimes you don't see all the applications that are possible with it. For example, I thought we would almost never need a larger print area. I thought, well, we can just make do with enders. You know, you can get 2 for the price of one CR-10 kind of thing, and just print your parts in half on 2 enders instead of one large machine. But actually, downstream and in terms of part simplicity and part design, and what this is kind of what we'll talk about today, but it does make a lot of sense to consolidate your parts where you can. And plus, there's actually a whole domain of things that that are large that you interact with on a daily basis that wouldn't make sense to print on an ender. Like I could see the CR-10 being an amazing machine with a massive nozzle, and you can print things like furniture, for example, or generally parts that are awkward shapes or too large to fit within a standard printer's build area. But on something like a CR-10, you could easily do large parts like that.
Yeah, I remember with my smaller printer, it was like 200 by 200, and I actually had parts that would go like diagonally in midair because I couldn't fit it. I couldn't fit it like on a flat, and I couldn't fit it on the diagonal on the print bed. So it was diagonal in X, Y, and Z, just to make it fit. And I used so much support material. It wasn't good.
So there's actually a lot of stuff going on in chat right now we should probably look at. So Benny Brady says he's got the CR-10S with the E3D Titan Arrow. So this is basically what we were just talking about. Where with the Volcano Hotend, Titan Arrow Extruder Volcano Hotend uses 2.85 millimeter filament through a 0.8 nozzle. Yeah, that's exactly
that's good.
The kind of thing that I see the CR-10 or Sidewinder or these kind of, they're actually on the smaller end of large printers, but they're in the realm you'd consider this is a big printer. That's exactly, I think, the ideal setup for them, because you can start printing like internal structural parts for furniture. I mean, even potentially in automotive, like larger plastic assemblies could be consolidated into bigger parts. And even though you're using a huge nozzle, that actually, bigger layers or bigger, layer cross-sectional area results in stronger parts. So you can actually start looking at, making big, strong parts on these machines. And there's actually some challenges with manufacturing large parts with injection molding that you can kind of ignore, or mostly ignore, with 3D printing. For example, doing really large, completely solid parts, or even injection molding parts that have like a really big cross section that's fully solid is actually really difficult to do, because the bigger your part, the more mass you have to cool, and the longer it has to cool, the slower your mold cycle is going to be. So there's
also like shrinkage, warping effects.
Yeah. So you'll see like a lot of big parts end up being like kind of hollowed out shells with, what are those like cross supports called? That,
what, ribs?
Yeah, ribs that try to give it structural integrity. But you can imagine, like, okay, well, if you 3D printed it and used an infill in the correct orientation, it's going to be much stronger than those ribs and still take up the same amount of space.
Yeah. and then you can make certain parts actually solid if they need to be, without losing um, any aesthetics or strength
Is
or
fo-
warping.
yeah, Kevin's asking if 40 centimeters is considered large.
I'd say that's large.
Definitely.
So Justin 3D says CR10 is mid-size. I guess that makes sense.
I mean, when you, yeah, there's
There's
like a class of printers.
F5, which is 500.
Yeah, and there's a this is like a large desktop machine, right? There are classes of printers that are far larger.
You've seen those house printers? Those would be
Like
extra large.
concrete printers.
Yeah.
But I'd be curious, anyone who's watching, everyone in chat, like what is the largest printer that you have printed on or own? And maybe as a follow-up to like what is like what kind of parts were you printing that you needed all of that print area? Because we're fairly new to large format printing. We're mostly relying on feedback from the beta testers with this. So I'd be really curious to know actually.
I know another popular one is just printing props and
Yes, yeah.
costume accessories. Like some of my friends actually need props like helmets and large
Like wearables, right?
like wearables. Yeah, like I actually printed a massive skull. And my Ender 3 was actually just big enough for that. But if I was gonna do this thing for more than just, you know, a couple friends once every few months, I would try this on a CR10 because it would make it a lot easier.
Yeah, for sure.
Because I had to print my skull like weirdly shaped. It was like standing up on its end. It wasn't very sturdy. But yeah, also if you're going to be post-processing it like with a mask, for example, it actually makes a lot of sense to use like what Justin 3D has, like a really high flow hot end, print thicker layers. Doesn't really matter because you're going to be putting filler and paint all over it anyway. So
Yeah, right.
these kind of things are really suited for 3D printing because, you know, if you're going to do extra work on it anyway, then it doesn't really matter if the layers are, you know, 0.5 millimeter or 1/4 millimeter.
Yeah. Yeah, I mean exactly. And those parts are gonna be so strong. It is kind of the perfect size for like yeah, wearables, armor sets, props, anything
Yeah.
that you would hold kind of on camera that's bigger. Um, even things like so with automation, when you can have a ton of these, you could even do things like you can imagine on a movie set, a lot of background stuff has like custom paneling.
Yeah.
And if you wanted to do some really intricate paneling, you could easily print that on these types of printers and cost you next to nothing.
I guess there's a lot of applications for like board games and stuff too. I know people print custom terrain, that kind of thing.
I've done that on but really small custom terrain on my
For like a
Ender.
Catan set, right?
Yeah, yeah. I think we showed it once. Okay, so let's see. So Justin says he likes the 4x8 by 3 foot printers.
Feet. Wow.
That would be
What are those? Those are like big long rectangle things.
that'd be cool to I don't know whether like manufacturing vapors that are larger is very difficult and that was one of the things that we had to figure out for CR10, but there's even requests for larger sizes, and I'm quite curious whether you know it scales to that. It in theory it should, but the forces involved on printers that large, like the warping forces in your plastic, are insane.
Yeah. Well, it'll be cool to see how big of a part we can print on a vapor while having it released so nicely. I think that'll be cool.
Ben says the CR10 Max with 47.5 centimeters squared bed. And then Justin says Eric Woldridge, who's been on our stream many times, has an extra large printer, 3 by 2 by 2 meters.
That's massive.
That's huge.
Oh, is that still an FDM printer or is it using like injection molding
Like
pellet
With
system?
pellets, yeah.
I'm assuming that's what it would use. Otherwise, why would you have it print? I think it's pretty funny actually that the CR10 and stuff still comes with like a 0.4 nozzle.
Yeah, I know.
It's
It's
like,
kind of ridiculous, actually.
did they not know that it's better to print with a bigger nozzle on something this big? Like,
Yeah, it
come
is
on.
kind of funny. And then, oh, Ben's got a Coreception 300 as well. I've actually never heard of that printer. Maybe we should look it up.
Let me guess, it's a Core XY printer, 300 by 300 millimeters.
Probably. And then the CR-10S S5 is a 500 by 500, but it's a nightmare. And I'm assuming that's because of the mass. If it's a bed slinger, the mass of the actual print bed might be
They do
ridiculous.
have two motors on the Y-axis for that printer.
Oh, they do?
It's a double Y-axis motor. Yeah.
That would make sense.
Because
Imagine tilting that though.
yeah. Well, maybe the two motors cancels that out.
I mean, the one motor does fine with this one.
Yeah.
And it can still go pretty fast, so it's not. So Justin was using the big printers for bumper and car parts.
Oh, nice.
That makes sense. That's what you're usually seeing it. And actually, the guys from Polymaker, we should have asked them a couple weeks ago, because if anyone was watching that stream, they were 3D printing like pieces of car chassis and internal structure for cars. Maybe I can pull it up on the web browser real quick.
Got a plastic or what?
Yeah, yeah.
Oh,
Out
wow.
of their materials. Polymaker, yeah, I'll pull it up.
That's pretty cool.
But that's exactly the type of you know, type of thing that large format printers make sense for. And those are also high volume applications. Here we go. I've got it right here.
Oh yeah, this is the
So
one we talked about last time.
yeah, yeah. So a lot of the parts on this vehicle are 3D printed, FDM printed with Polymaker materials. But this is like exactly an application of high volume printing where automation could easily come into play, because you could just have a set of large format printers on, you know, on your production line, producing parts at the correct rate that you need for the line to keep running. And
yeah.
You don't have to worry about like crazy logistics and organizing shipping to bring just the right amount of materials per day.
Yeah, and actually large parts tend to also be lower, like you need lower numbers of them. Like you're not 3D printing bottle caps, for example. So if you have a large product, that usually means you're not going to be selling as many of them, so you're not going to be needing as much like bulk processing.
Mm-hmm.
So being able to pump out like 20 parts in a day or something with your CR-10 print farm could be totally reasonable, because you're only like selling 10 or 20 parts a day.
Right.
Just because they're bigger, people, don't tend to buy tons of big things at the same time.
But it's also, it does, one thing you'll see with large print farms, which is interesting, is they tend to have a lot of printers. And I think it's because each print takes so much time.
Yeah.
So in order to maintain output, they need to have more printers. But as we all know, more manual printers starts to become a nightmare to manage, especially once you get over 20 or so. So that's where we also see the automation really coming into play, where for these print farms that are doing like that have 20 or so CR-10s, it would optimize, it provide an insane production boost.
Yeah. Justin 3D says days and days of printing. Yeah, that's true. We're actually going to talk about that later in the stream, because we really don't want things to take days and days. If you're running an automated print farm, you want your prints to be as quick as possible while still being a good enough quality. So we're going to show some tips actually on how to increase the print speed while we're keeping the same quality.
We got
for large parts.
Also got a comment from John Beatty about what he used large format printers for. At his previous job, he had a 3D System Pro X 800, an SLA machine with a 26 by 23 by 28 inch area. So that's like that's a pretty big SLA
It's what,
area,
600, 500 by 500,
roughly.
something like that?
Yeah, yeah.
Yeah, 500 cube.
And they are printing parts for wind tunnel testing, as well as panels to design the NASCAR Ford Mustang a few years ago. That's crazy. But that's
Pretty cool.
but that's like automotive now. Your
Yeah.
panel design, um, which makes sense. Which is something that's pretty inaccessible to the smaller volume printers. Although a lot of people would say most parts printed are, I think it's like most parts printed are under 15 centimeters in their longest dimension.
Yeah.
But I think that statement is kind of misleading in the sense that it's also partially because those parts print faster, so you'll be able to make more of them. That doesn't mean that the value is completely in those small parts. There's a lot of value to be created in pushing large parts to higher volumes as well.
Well, there's also that kind of like self-fulfilling thing where people don't design big parts because they don't have a big printer.
Right.
So they design them to be smaller.
John said,
Whoa, that's a lot of money.
yeah, that's he says for that SLA machine, it costs 72,000 US dollars to fill the vat.
What was it made of? Like metal powder? Something?
No, it was made of 3D Systems material.
Oh yeah,
That's
so
how
like
much
some
it
sort of
costs.
nylon or something.
No, that's just how much it.
What is that? So that's almost like
That's like
500 by 500. How much is that in cubic meters? It's a lot of material.
Yeah, but
So
that's
it's like
also
half a
like
cubic meter or something.
I'm saying that's also the
Expensive material.
yeah the place that would charge you 240 US for 1 kilo of PLA.
Yes. It's got a very nice NFC chip on it though.
Yes, yeah. Right. So he converted his CR-10S because he had a part. Okay, so Ben,
I love this.
we talked about the volcano nozzle, and actually, why don't we get into slicing
Yeah.
for big parts? And I'm sure a lot of the people watching are gonna have tips to contribute. But Ben, who we earlier talked about, had the volcano nozzle on his CR-10. Converted it because some of the parts that took him 76 hours to print would now only take 32 hours. So you're cutting that time in half with just a nozzle upgrade, essentially.
Oh, and speaking of nozzle upgrades, another good one to consider is that new CHT nozzle with like the triple
That's
bore.
gonna be interesting for large format machines for sure.
Yeah, it's looking like it's probably like one of the best bang for your buck print speed increases you can get. Just from the videos I've seen so far on it, but I really want to get one to try it out. But I think, yeah, for CR-10, these kind of upgrades really make a huge difference.
Bob's in chat too. Welcome, Bob. Nice to see you again. Johnny is saying you look like a young Elon.
Who is Mateo?
No, you're on the left.
Oh, I'm on the left.
Yeah, Elon.
Ah, nice.
I
thought it flipped our screen, that's fine.
What crypto scam are you gonna push on us this week?
Well, I don't want to say Dogecoin 2.0, but
Q coins.
Q coins, yes. Yeah, we've already done that actually.
Yeah, we've got that in our shop.
I'll take that as a good compliment.
Oh, I can barely keep up with chat. Holy moly. Okay, John did the conversion for us.
Oh, thank you, yeah.
Okay, yeah, so you were pretty close.
My freedom units aren't too bad.
Unveiled HD.
He just joined the Discord fairly recently.
Oh, cool. Okay.
Yeah.
I think I saw him. All right, well, shall we go into Cura and talk about slicing for big printers? And yeah, if any of you guys watching have tips, shout them out in chat and we'll see what we can do.
Yeah.
I'll hand it off to you, Steven, actually, because you're...
Sure, let's do some slicing.
You're better at slicing than I am.
Yeah, so today I think we'll be doing a really big benchy. Just to do one. I think it's in our downloads folder.
That's where all STLs belong.
That's the typical location.
All right, we got a small benchy here. How big do we want to do it?
Well, why don't we just fill up the build volume, keep it diagonal maybe? Yeah, look at that. So it'll be cool what the so the Cure profile has like default settings um with like, you know, 0.4 nozzle, 0.2 layers. Actually, should we do bets on how long this print will take at default quality?
Oh, we should.
And people in chat,
Okay.
take your guess. How long will Big Benchy take to slice using the standard quality settings in Cura? I'm interested who gets the closest answer.
So the dimensions are 254 by 254 by 240 centimeters, or in freedom units, it's about 10 by 10 by 9 inches. We'll have to wait a little bit for chat to catch up.
Yeah, that's true. Oh, and we're also covering the print estimate, so we can actually just slice it and they won't see what we get.
Oh, right. Do you want to guess?
Oh, sure. Wow, this is gonna be hard. I want to say like 3 days.
We're at 0.2 layer height. What is our infill?
Oh, maybe even more.
20% infill. So
This
that's
is hard.
0.2 layer height is 5 times. Oh, I can't do this in my head. 4 times this would be 1,000, so 10,000. So
I'm just going off of intuition.
12,000 layers. Is that right? Or am I off by a factor of 1? I think that's right. 12,000 layers.
1,200 because it's 5 layers per millimeter.
Oh, this is millimeters.
Yeah. Yeah.
1,200 layers.
That's still quite a lot. I'm gonna go with my initial guess was 3 days. I'm just gonna go with my gut. I think it's probably an underestimate, but
I think it will be 4.5 days.
4.5. Okay, let's see what chat has to say.
Okay, let's check chat. 10 hours.
10 hours.
That's a bad guess. Armin says
3 to 4 days.
3-4 days.
Cool.
Okay.
2 days.
6. Oh, Kevin guesses 6 days.
5 days.
Johnny says 5 days. John Beatty says 32 hours. I think John is a bit optimistic. These are default Cura settings. Like
on Cura
noob
4.9
settings.
actually. We really need to update Cura on his computer.
That's true. Okay, John probably.
John Beatty downloaded the model,
Yeah, he
put it in
already
his
sliced
slicer,
it.
and sliced it.
Okay, let's see.
Let's see what we got here.
Let's do a big reveal.
Yeah, because we're covering the
Yeah, I'll fix that. It's slicing. It's chugging. Ooh.
And I mean, this is what lots of people do, right? They'll just throw the model in, hit slice, and then that's what they'll send.
Okay, Ben is guessing 6 to 7 days. Okay, I'm so curious now. Will. Oh, what? Okay.
Interesting.
2
Okay.
days, 14.5 hours. So who was closest?
I think it'll be me.
What did you guess?
I guess 3 days.
Oh, Armin guessed 2 days.
Okay.
Yeah, it's closer to 3 days. 32 hours. That's 1.5 days. Good job, Steven.
See, that's the intuition right there.
Good job, Steven.
This is why I'm here.
This is why you're better slicing than I. Oh wait, I transition it. Here we go. The big reveal. 2 days. Okay, so that's a long time.
Yep.
Oh wait. Wait. Stop the vote.
Oh, wow, look at that.
Stop the count.
It's gonna get closer to 3 days.
I scaled it incorrectly.
It's into the build plate. Just drag it up.
Does the ranging not work?
I think it just didn't automatically drop it to the build plate.
Okay, there we go.
So it's going to be
Apologies.
even closer to 3 days.
Okay.
Because it didn't print the whole thing.
Watch it be 4.5
It
days.
cut the benchies. Well, maybe the first layer will take forever. Actually, no,
No,
it'll still be the
it would
same.
take less now.
Well, it has
Oh
that
my
weird
God.
complicated stuff
What
on
a
the bottom.
goof up. Well,
I've spent so many hours slicing benches.
okay, it only added 2 hours,
2 hours.
you're still the closest at 3 days. And then I think also Armin said 3 days. He said 2 days, and then he
2 days.
said, okay.
Cool.
Anyway,
Sorry, I thought someone in chat would probably get closer, but
moral of the story, on average, if you averaged all those guesses, we were probably right. Wisdom of the crowd.
that's true.
Okay,
Someone can do the math.
so let's pretend this was actually like a functional part. We need it to look decent, but it's, either going to go inside something, or, it'll be painted over, used as a prop or a wearable or something.
Yeah.
So I think the number one thing that you would say, Steven, is let's switch out the nozzle on this printer.
Yeah. Let's put a 0.8 nozzle on it. Let's not go crazy. 0.1, you start getting to that stringing territory, and we still want it to look good. Did it automatically switch it to 0.32?
Yeah.
Okay. Hey, this is good.
So even Kira knows a little bit.
So do you want to see how much just changing the nozzle to 0.8?
I'm putting
Let's
it back
change
to
things.
0.2.
No, keep it to the default. Like we're gonna see if like someone who doesn't know what they're doing, they just change the nozzle size.
That's me.
Let's just see how much of a difference just the nozzle itself makes.
2 days to close.
2
What about
days.
with support? With support.
You don't support a Benchy, it's against the rules.
Yeah, that's
actually
illegal. My under 3 would have said 26 days, Johnny. So yeah. 40 days, 40 nights.
Okay, well, how long do we have here?
1 day.
One
So
day and
we've
5
already
hours.
cut a day and 10 hours off just by changing the nozzle width and the layer height slightly.
Yeah. So that's probably the best bang for your buck, is just change your nozzle diameter.
Yeah, and a lot of people will like go to crazy lengths upgrading their. I've seen people upgrade their motors to increase speed, but really all you have to upgrade is your nozzle. And in some cases with a bigger nozzle you need a better extruder, but we didn't push the speeds at all with this.
Yeah.
And I think the default extruder is more than capable of handling 50 millimeters per second.
Yeah.
It's a Titan. It comes with a Titan, right?
Yeah, so we have a CR-10 V3 here set up with Quinly. Comes with a direct drive Titan extruder. It actually has an E3D logo on it, so it's a legit Titan extruder. And yeah, it's direct drive, so
yeah, and if you
should be able to push.
Yeah, we do that on our enders, easy.
Yeah.
With their default ender extruder, plastic extruder.
The default ender extruders are still fine. I think
we've proven that over tens of thousands of prints.
Yeah, actually with those, everyone says they crack. We've never had one crack yet. It's very strange, but
no, we have.
Have we?
Yeah, I've replaced a few.
Oh, have you?
But
okay, I've never cracked
It's one of those things where they fail pretty quickly.
Either they fail quickly or they don't.
Yeah.
Interesting. Okay.
Yeah, so Ben was saying, like, with a 0.8 nozzle, do you have to slow it down? So we're pretty confident that you wouldn't have to slow it down from 50 millimeters per second. Even the plastic ender extruder is able to keep up 0.8 nozzle V6 hot end at 50 millimeters per second easy. That's actually, I think we
actually what we should do. Does this have flow? Showing on the
here?
Because in the layer view you can set it to do flow. I don't know if that's a new thing.
Yeah.
Damn, yeah, we really should have upgraded Kira, because new Kira has
they show
flow rate.
Yeah. Okay.
Well, we'll have
next time.
So yeah, if you when you have a better version of Kira, you'll actually be able to see the volumetric flow rate and find your like limit of your extruder and your hot end combo, and then you can just push it to as close to that limit as you possibly can.
Actually, I think it's an experimental setting in this version.
Volumetric flow rate.
Oh no, this is too old.
It's too old. Well, if you want to actually push your machine to the limit. Find your max volumetric flow rate, and yeah, get as close to it as you can in your slicer. But one huge improvement we can do to allow us to print faster is actually to just increase the hot end nozzle temperature.
Right.
Having a hotter temperature means it melts your plastic faster. And so, you know, if people are trying to push their print speed to the limit, but you're only printing at, you know, 200 degrees, the stuff that's coming out of your nozzle is going to be like 180 degrees or something,
Right.
because it didn't have time to fully melt.
So there's some cases where we're printing PLA at 240 or 245 degrees Celsius just to be able to push on our enders, to be able to push the speed on a 0.8 nozzle, you know, 60, 70 millimeters per second. And that's on the Ender Bowden setup. Just changing the temperature helps a ton. Actually, we should probably say all of our enders, except for 3 in our print farm, are running 0.8 nozzles. So this is the quality difference is actually quite marginal. Your corners aren't going to be as sharp, but for most parts you can design around that limitation. And since we're mostly printing our own parts, it's easy for us to just, you know, not expect you know, 0.2 millimeter radiuses on all our parts. Just avoid super sharp corners.
So a few things we can do now. So we now know for sure that our extruder will be keeping up with these print speeds that we're going at. But look at all this infill, right?
Yeah.
There are some things you can do about that.
Watch the video on again. Okay, let's talk about infill and then we'll catch up on chat.
Yeah.
All right, so infill. So if this is, you know, not something that requires uniform strength throughout the part, if this is just a part that you need printed that needs to look good, there's an amazing setting in Kira called, what's it called?
Gradual infill steps.
Gradual infill steps right here, where basically you can tell it to only print max infill right at the top of your print where it needs to support those ceilings. Everywhere else, it can do less infill. So right now we're at 20% infill density, and if I do one gradual infill step, what that means is it's gonna start printing at 10% infill and then step up to 20%. And you can define a whole bunch of really interesting things like how much height you want for this step, and it's counted from the top down. So right now it's set to 1.5 millimeters, which means 1.5 millimeters from the top of our print, we're going to step up from 10% to 20%. So you can see here, everything is 10%, but as soon as a flat surface comes into play, you can see, like in the middle of the screen here, the infill will double, and it'll double for 1.5 millimeters. Now, I would probably recommend, especially when you do more gradual steps, so you can see here it's 20% infill, but just below that it's at 10, so that, you know, halves your infill time. What I would recommend is making that gradual infill step height a bit more, because you need that higher density infill to be solid enough to support the layers above it. And when you're printing really fast, you know, those are going to droop or they're not going to connect if you just do one layer of high density infill. So I would set it to probably, I think generally I'd do it like 5 layers before. I don't know. Do you agree with that?
I would say 5. I mean, in this case, it was pretty much 5. 3.2 times.
Yeah, maybe it would be more.
It would have been 4, maybe. Depends if it rounds up or down.
I think I would probably do like,
I think just 2 millimeters would be reasonable.
Yeah.
So we'll see how much that reduced the print time. So it was an hour and, or a day and 5 hours and change.
Yeah.
So we'll see how it does.
So it saved 4 hours, but on a day that's a decent amount.
Yeah. So in terms of like percent, it reduced print time by like 15%, something like that.
Yeah. And but it reduces your material usage quite a lot as
True.
well.
Yeah.
So if it's not critical that you have 20% density infill everywhere, this is a really good way of saving material. But what we can see here, I mean, immediately is the infill is not what's taking up the bulk of the time in the print. It's our perimeters. So
Oh, you can actually hit the info button at the bottom, and this actually tells you the breakdown. I didn't know about this for like the first few like years of printing, but
so infill is taking 5 hours, and the walls are actually taking 12 hours, so taking 50% of the print time.
mhm.
So, I mean, the easiest thing to do, and the skin also is taking 16% of the time.
You can usually speed up your inner walls quite a bit. I
Well, let's
know
see what the default speeds are, because they're probably really slow.
the default speeds, I think
Oh
the
yeah,
inner and outer walls
25.
are the same. So you can usually get away with much faster inner walls, and then you just keep the outer walls really slow to keep the quality up.
I
So
don't
this
know. My
will,
inner walls are always like 50,
yeah,
but then I would also bump the infill up higher, maybe 60.
60 should be fine. We can also I'm actually curious if Justin, was it Justin that had the huge setup?
Yeah.
Justin, if you would like sort of be able to tell us how long it would take you to slice a big Benchy. I'm curious what your setup is capable of. Because ours kind of assumes this stock Hotend and extruder combo. But if we had a Volcano with like maybe a CH-10 nozzle or something, I'm pretty sure we could get double or triple the print speeds that we're going for.
So, yeah, Johnny's asking what contributes to printing fast, and yeah, just keep watching. A lot of it comes down to your slicing settings. There are a lot of small settings that'll just screw up your entire print time, that you want to make sure are disabled. Um,
Yeah, so
Steph
what
was saying we were printing 55 grams per hour on an Ender 3. That was a 0.9 extrusion width out of a 0.8 nozzle, which we can talk about pushing extrusion width.
yeah.
Um, with the stock extruder, but with and a V6 hot end, and we just kind of made it really hot. I think it was 245 degrees Celsius, and it was a vase mode print, so the part itself was never doing any retractions or slowing down.
Mm-hmm.
So we should talk about vase mode too, even though it doesn't apply.
Yeah. Yeah, because when you do Vase Mode, you lose no time to travel moves or retractions.
And you'll see here, travel is actually 10% of our print time, and retraction is another 9%. So actually together they make up 20% of the print time. So if you can design your parts to be in vase mode, maybe show the ramp again.
Yeah, this guy's in Vase Mode. Oh, I wonder how long it takes. I forget how long these take. But they're like less than 2 hours, I think.
Yeah, these guys are pretty giant prints, but they only take 2 hours. And it's simply because they're designed to be printed in vase mode. So just by virtue of that, you instantly save 20% of
I
your
wonder if you
print
can
time.
see.
Put it against the yellow.
Yeah. Anyway, they're
It's
very thin.
It's too dark.
Well, I wonder if the B cam will show it. Maybe the B cam will show it.
Okay, let's show the peak now.
Because you can see that the top is actually just open. Yeah, here we go. The top is just open, and like these are plenty strong enough.
Yeah, Ben says
Watch it break
retraction
as
is retraction is what kills you. It's true.
Yeah.
And you have no retraction with vase mode prints. 3D printing is not a race.
It can be a race.
So it doesn't, your print speed doesn't matter as much if you're not at your printer 24/7. But when automation comes into play, it becomes a huge factor in your output because Quinly's running your printer 24/7. So you no longer care about, you're no longer losing time to prints finishing fast and then sitting there waiting for you to wake up in the morning to remove them. Because with Quinly, they just get removed right away and it moves on to the next one. So it actually makes a massive difference. We always talk about the tests that we did. We did 1,000 hours of printing, and we were printing these face shields for COVID. And the initial slice time for the face shield was, I think, 2.5 hours. Oh no, 75 minutes.
Yeah, it was over an hour, I think.
75 minutes. And through slicing optimization and
we remodeled the part
we remodeled the part.
to be like line width multiples.
Yeah.
So there wasn't any weird zigzag shuffling by the printer.
Infills. So it's almost like a precursor to making it print in Vase Mode. Kind of.
Yeah. That was before we knew about the Vase Mode tricks.
Yeah.
But also that part wouldn't really print in Vase Mode.
Right. But so that took it from 75 minutes to 35 minutes. And over the 1,000 hours, we printed something like 920 parts. If we didn't do that slicing and model optimization, then we would have gotten less. We would have gotten
like 400.
Less than half the parts in the same period of time. And if you're selling these, that's less than half the revenue from your printers, just because you didn't spend an hour or two extra making sure that your part is sliced for speed. So speed becomes a very, very critical component with automated printing.
Yeah, it's actually something that you get good at once you have an automated printer, because you don't feel like squeezing an extra 5% of print speed on a thing that you're only going to print once. But if you're going to print 100 of them, then it really, really, really makes a difference. And actually, was it Ben that just said, like, print speed increases means the quality lowers? It's not always the case. So, like,
Depends.
You can get away with a lot of stuff while keeping the same quality.
There are a lot of tricks.
Yeah.
I guess we can go back into Cure and talk about that. Especially with these perimeters, one of the tricks are just keep the outer perimeter really slow, but make everything inside much faster.
So check out the new time. We didn't show the new time, so we dropped another 3 hours.
Right.
By changing the speeds.
Let me just revert it. So we have 50 millimeters per second infill, 25 millimeters per second walls. I love how Cura takes like a different amount of time to slice every single time. So that goes from a day and 2 hours to, we had 60 infill, and then only the inner wall was increased to 50.
Yeah.
The outer wall stays the same speed, so the outer surface of the print is going to stay the same quality. And here you'll see. So it drops it by 3 hours. So another 3 hours have been dropped. And you can expect a very, very similar level of quality.
If not, like, identical.
Yeah. Now, there are some cases where if you go overboard on your inner wall speed, it will affect the outer wall as well. So that's not generally something you can crank up to an insane amount. Yep. That being said, things like infill are a bit of a different story. In some of my parts, I've put the infill, up to 80 or 90 millimeters per second, especially if it takes up a lot of time. Right now, it's only taking up 20% of the print time, so I don't think I would push it any faster than this.
And so do you want to take it one step further? So another thing you can do is increase the line width bigger than the nozzle.
Right.
So for some things like top surfaces, for example, you can get larger line widths and still get the same quality.
I'll show 2 tricks on this.
Okay.
So the first one is what Steven said, which is just increasing the line width, meaning that your nozzle covers, more area in each pass. But that's obviously going to lower the resolution of your print, especially top surfaces. There is a trick to get around that.
Because one thing I like to do is keep the outer walls like the nozzle diameter, but then actually for the top surfaces, make the lines really big, and then use a cool setting called top surface skin to make the visible top surface back to normal, so it actually doesn't look like there's gaps.
What's the highest you've gone on a 0.8 nozzle?
Yeah, you can go like 1.1.
You've done 1.1?
Yeah. Well, I've actually done 1.3, but I didn't like it that much. It was pushing it too far.
Let's do one.
You can just do 1.0.
Let's just do to be safe, to be a little conservative.
Yeah.
And then, so the nozzle width is 1. And then because we have a 0.8 nozzle, we can drop all the way down to 0.8 to maintain quality. And so what's most important, the extrusion width actually doesn't affect the outer surfaces very much. Although if you have things like embossed text, it will affect those because the radius of your extrusion is bigger.
It'll be a little bit less crisp.
So what you can do is change the outer wall line width back down to
This is the way.
0.8. And then there is a secret setting. So let's just show this first. Not secret, just experimental setting. You'll see the text remains crisper, but on the top surfaces, there are going to be fewer passes. So you can see the density, like the back and forth, is much lower. So that saves a whole bunch of time. But what you can then do, if you want to preserve the top surface quality, is there's a setting called top surface.
I think they actually put it out of experimental.
In this version, though?
Just search it. I think it's
Skin.
now kind of, yeah, it's just top surface skin layers right at the top.
Oh, okay.
So set that to 1, and we'll get.
But then we have to set the skin
the line width.
width.
The rest of the settings are in experimental.
It is under experimental. So you can do.
So I actually do 0.6 for this.
With a 0.8 nozzle?
Yeah, it actually kind of irons the surface.
Right.
So this is like secret ironing. It's not as good as ironing, but it's basically just ironing. So it doesn't go over the same area twice. It just does it once, but it
kind of, the nozzle
squishes,
overlaps the previous line.
Yeah.
So we've actually we've got a much better top surface quality, but our print time has not changed. It's still between 21 and 22 hours.
Yeah, so just maybe increase the print time very slightly because it's printing just the the visible top surfaces at like maximum quality, and everything else below the top surface is like really thick lines.
So you can see these are the 1 millimeter line width, and then the very top surface that you see actually drops down to 0.6.
Actually, are the lines doing the crosshatch? They should be doing the crosshatch.
I'm just not scrolling.
Oh, you're not going one by one?
I'm not precise enough, sorry.
You can use the arrow keys, actually.
You use some kind of Cura Pro?
Yeah.
Okay, so you can see these are really thick, and then these are really thin.
Yeah. Cool.
Okay.
So we're getting pretty close to, I would say, pretty optimal.
Do I get a Discord tag for watching this? If you share the stream, we'll give you stream supporter tag.
Yep. Post us on social media and send us a link of you posting it on social media. So that could be Reddit, Instagram, or another Discord channel.
Ben has a question. When Quinly moves the part off the bed, is it using the hot nozzle? No, it waits for the nozzle to cool down. The nozzle cools down a lot faster than the bed cools down.
And actually the part pushing off is usually the extruder box, unless your part is super thin.
Then sometimes it just falls off by itself too.
Yeah. Like
And then,
usually the nozzle itself will only contact the part if your part itself is like 1 or 2 millimeters thin. Otherwise, it'll just hit the extruder box.
Justin's asking, what is the height that Quinly can knock off at? We've done production runs of parts that were 1.8 millimeters in thickness. They were those ear savers that go behind your mouth. So that's the thinnest that we've done hundreds of parts of. You can technically go thinner, although depending on, your nozzle, things might wedge under your nozzle any thinner than that.
Yeah. So the nozzle itself is at 0.5 millimeters as it clears. So that's the lowest you can get without kind of risking damage to the bed. So the theoretical limit is like 0.6 millimeters. So I've actually printed really thick skirts at 0.6 millimeters tall, and they get cleared by the nozzle just catching it.
Yeah.
But I wouldn't reliably say that you can clear any part that's 0.6 millimeters tall.
We've never done it ourselves. We've done 1.8 for hundreds of parts on multiple printers, but we've never, done production runs of less than millimeter thick parts before.
Yeah, I've done 1.5. That's about it.
Nice to see Robert in chat.
Hello, Robert.
Kevin's asking for the OG tag. We're gonna have to.
True, yeah, Kevin is an OG.
He does get has to be somehow like stand out from the crowd as an OG original gantry.
Original gantry. Whoa.
Okay, are there any further optimizations? So we've talked about infill stepping, and we've also kind of done a sort of stepping. We've done a sort of stepping with the top layers by stepping down the width so that we get really nice top layers.
But the layers below them are thicker, so they print faster.
Yes. Where else could we save time on this part?
Check out the top and bottom surface speed. Those are probably super slow too. I guess they're they can be pushed because the top surface skin speed will be different.
Right. So what Steven is saying is this very, very top most visible layer here. Oh, why did we do that? Cura. Right, so these underlying layers can be faster, and then we can make this top visible layer slower. So top surface skin speed, so that's at very top, 25, and then top bottom speed, what do you want to increase that to?
Let's put it to 40. You don't want to go crazy.
So just keep this one at 25.
And that stays at 25, just to make it look super crisp, super good.
What was their original print time? It was 2 days and 16 hours?
Yeah.
Okay. So now we're at 20 hours.
So I think we shaved another hour and a bit.
Yeah. So now we're kind of at the point where the outer wall is taking the most time, which can't really avoid if you want to maintain quality. I would say that you could easily get nice quality prints with an outer wall speed of 35. But I think for the sake of this, we don't have to increase it.
Yeah. At this point, if you want significant increases, you're going to have to do either hardware upgrades or thicker layers in general.
So yeah, consider that this giant model, right? We're still printing at 0.32 layers, which is a relatively high quality. Our Quinly parts, because we don't try to hide the layers and we do them in Vase Mode, those are at 0.5, some of them.
Yeah, actually these ones are at 0.32.
Okay.
But our ramps for Prusa, for example, are in 0.5 layers.
Our ender ramps are as well, aren't they?
Yeah.
I don't see it one here.
They'd be hard to show on camera anyway.
Yeah. We'll post photos in the Discord channel if you guys want to join.
Yeah, honestly, I think we should try that CHT nozzle. I agree. On the CR-10, it would be really cool. Machine Creators is saying. But a 0.4 millimeter CHT, so that would be one where you can double your print speed while like keeping that really crisp nozzle diameter.
The flow rate increases by the square, right? Or is
It
it
increases.
3/4 square?
It's like the nozzle diameter increases one dimension of your print.
Yeah, it's not exactly that the circle gets bigger, because only
The line
gets wider.
gets wider, so it doubles. If you double your nozzle size, you should double your
I think it's a little
speed.
a little bit more than double.
But also, when you double your nozzle size, you can also double your layer height.
Right.
So that's the second dimension. So in theory, yeah, if you can double your layer height and your line width, then you would square root your print time. I think
Okay.
that's how it works.
I see.
By a factor of 4. No, it would get smaller by
Factor 4.
factor of 4.
Right. So are we happy with this? Oh, let's get rid of that skirt. Get that out of here.
Skirts.
That's the most costly or let's do the trick with the skirt. Skirt distance is a 0.8 nozzle, so we would do 0.7.
I've started doing 0.7 is what I do now. It's just a little bit closer. Because for some reason with 0.4 nozzle, 0.4 is perfect. 0.8, 0.7 is perfect.
Mm-hmm. Probably because of the speed. We're not getting true 0.8.
Mm-hmm. Should I level this thing?
Yeah. Why don't you level this thing and I'll read chat. So there was a lot of chat while we were talking about this. All right. All right, chat. We've got Robert in chat. Original gentleman, Steph says. That's what OG stands for. Oh, I'll talk about, because Machine Creators asked about larger print surfaces, and someone right at the beginning of the stream, I'm just trying to scroll back up, also asked about, I think, the Ender 3 Max. So, as part of the production of CR-10 and Sidewinder beta kits, I've also made some 350 by 350 millimeter beds as well. So that means if we get enough people signed up for betas on a printer with that size print surface, we already have stock of vapors produced, which is generally the longest lead time part. So yeah, it's kind of primed. So if you want to do to beta Quinly on one of those larger area machines, and you know other people who have that size machines, get them all signed up. If we get enough people signed up for the beta program for a particular model, then we'll do it. Who would ask such a thing? Right, it was John. John and Jeff asking for larger printer sizes. But yeah, so in order to actually enter a beta though, we do need a decent group of people. So if you know or are in any communities that have like I don't know if there's an Ender 3 Max cult that you're in, definitely reach out to your friends there and get them signed up as well, because that's the best way to have a beta move forward. We need a lot of testers for this because we're talking about producing a system and software that can manufacture on the scale of thousands or tens of thousands of parts per printer. So that means a lot of testing is in order. If you're interested and excited about any format machine really, reach out to those communities and see if you can get some people signed on with you and join you in the beta testing cohort. Now, oh, Ender 3 Max is 300 by 300. Well, we already have this. These beds would fit on that then.
Yeah, that's what I was thinking. The Ender Maxes would be quite easy to
Okay. Well, it's the
be one
same
of our next ones.
same thing basically. Same. If you are in any communities or know anyone else that has them, get them signed on for the beta as well, because that's the fastest way to get new printers set up. And there's a lot of testing that we have to do in different environments. That's what's critical, right? So different environments, actually, it's one of the biggest pieces of learning we had when we first launched Quinly, because we sent out in January a bunch of, or people received kits in January, and it was the first time we had deployed in so many different environments. So we had to compensate for that in our software to make sure that the automation would work in a reliable way. And so it's the same thing whenever we support a new printer, we need to get a whole bunch of people, who are excited about the automation, who are willing to test something new, and a bunch of people who have different printing environments, so that we can make sure that the development process works in all these environments. And by virtue of that, it means that the system is really easily scalable, because you're no longer, you're not going to run into environmental issues. You can kind of put a Quinly on any printer in any reasonable location.
I think they're good.
There is a thread called, Kevin, you're going to be so excited when you receive your package. I include a very special gift for you. Jack's not in chat, but he got a very special gift as well. And it's like the thread. I mean, if there's enough interest from the thread community, we'll legitimately support it.
That's the weird thing. Yeah, we'll do it.
Yeah, we'll actually do it. I mean, if there's a case to be made. And that's not to say there isn't, because a lot of parts are small. So why, you could pack like 20 threads in a shoebox and be making thousands of parts on your threads. Justin, my environment is just the garage. I feel like that is probably most of our customers' environments. Garage or warehouse of some sort. So that'd be perfect. Oh, you got it leveled?
We're level.
I hope so.
Yep. We're at, our IP is 81.
Now everyone will know our IP.
Oh no. Hopefully, they don't control our Quinly. Oh no.
Okay, let's send it off. You got a web browser open.
So, interesting fact, we didn't actually have any 0.8 nozzles. This is a 0.6 nozzle.
Oh, really? Okay, let me reslice it real quick then.
Do you want to just run it? Actually, 1.0
No,
lines
it will
on this.
fail for sure.
Yeah, okay.
That's more than twice the nozzle.
Yeah, but
We'll
we do want to
0.8.
show it printing.
We'll do 0.8. We'll do 0.8.
Yeah,
Right?
that should be fine.
Okay.
We're engineers,
We'll
trust us.
see. We'll see. We'll see.
Oh, check out. We should do the first layer epic settings as well.
What?
Like increase line width on the first layer, for example.
Did we not do that?
We didn't. So like you could set it to like 110 or 120% line width.
Yeah.
Because we should do this for
Yes.
CR-10. So like 120% line width to get better adhesion to the bed is super important.
And the bed temperature needs to be 60 for this PLA, right?
Yeah.
Or 65?
60 should be good.
I hope the...
If you do it on top of glass, then you'd want to bump it up to 65. But we've adhered our vapor directly to the aluminum.
I think they're seeing that right now. Yeah, they are. Okay, so I'm just in Kira.
Oh yeah. What was the other one? Our initial layer height as well, we could increase it to like 0.4.
Yes. 0.4. Yeah, because we also don't have any ABL on this. This is just
Pure manual.
Steven leveling.
Yep.
Which, yeah, not super duper recommended. Although the CR-10 has a dual Z, so it's a lot stiffer. I've noticed that the X gantry sag is usually what gives me the most issue with printers without ABL. We actually like using inductive probes over BL Touch. And I saw some discussion in our Discord today about the fact that BL Touches, for some reason, are breaking really often on large format printers.
Yeah.
Did you get rid of our start G code?
Yep.
Okay. Just checking. All right, so let's head over to
Are they gonna see our Quinlys? Yeah, our new UI.
Yeah, if you haven't upgraded already, it's available on the resources page. I would highly recommend using it because it just makes your life way easier, even compared to the old UI.
Yeah, some people are saying 0.6 nozzle, it's a good compromise between speed and quality.
It's a pretty great compromise, yeah. Okay, so let's upload. That was fast. I guess it's not that big.
Too fast. What went wrong?
No. The file is less large than I expected for a part of this size.
Because we optimized it.
Oh wait, I clicked on the wrong one. Oops.
We would have gotten a helmet.
Just a random helmet I was printing. Yeah, that's good. Do we want
Do it.
more than one?
We can
How
set it
much
to
do
whatever.
they weigh? Behind the activate windows. 225. So we could print a couple. We should print two. Just to see.
Yeah, why not?
Okay.
Full PLA.
Oh, it's already picked up on the printer.
It's heating? Yes, it is.
Cool. Oh, now the hot end's got to get up to 245.
Now let's see if the Steven leveling was good.
Yeah, the Steven leveling. We'll see.
Haven't needed to level a printer in like literally a month or two, so.
Pat's saying he's mostly using 0.6. Ben is using 0.6 on the core section. Kevin is using it too. Yeah, so that seems to be the meta right now is 0.6. Yeah, I guess especially if you're doing more aesthetic prints, it makes sense to do 0.6.
If anything, retractions become better.
Yes, for sure.
I find that's the best improvement when you go a lower nozzle.
I guess, yeah, because of the
Let's see how this does.
Oh, it didn't scratch the bed. That's a good start.
Very good. Cool. Do we have the print cam going?
Oh yeah. Maybe they want to see as well.
How good can Steven level a bed on his first try? How's that? It's pretty good.
Pretty good. Robert's, I'm still using 0.4, Dad.
0.4 is too small.
There's a place and time for 0.4.
Yeah, we have actually 3.4 millimeter printers. We still use them.
Ben's saying he uses a BL Touch on his CR-10S, I guess referring to my comment earlier. It's been flawless for 2 years.
Yeah.
So yeah, I guess people are having different experience with it.
I know Machine Creators was saying earlier that he has 2 BL Touches that were like the chosen ones and they've never failed.
But the other
and he
ones
has like
did?
10 that have failed. So it's, I
Oh.
guess, one of those instances where if it
Okay.
fails early, then it's gonna fail.
That
Whereas
sucks though. Those are
if it gets
expensive.
past, yeah, no, 10 BL touches failing is a lot.
On our production machines, we use these inductive probes from Amazon, and they've lived for uh,
I just realized there was a weird setting we still didn't
a
disable.
year and a half now. Oh,
It was avoiding random stuff that it didn't need to avoid.
right. That's fine.
Yeah, that's pretty nice quality for the first layer, hey? Should I try zooming in?
I can zoom in.
Oh yeah, you can. We have technology, don't we?
We have technology.
Oh,
That's
that.
kind of grainy, but
I can move the camera closer too.
sure.
Combine physical and
You have
digital.
people motion sickness? Okay, let me transition away.
Just do it. Yeah, just do it in
Okay.
the other screen.
Okay. So people don't get motion sickness.
Can you see it from there? Yeah.
Yeah. Okay. Perfect.
So this is the super good 3DQ first layer settings we recommend. So boosting the line width, boosting the layer height, boosting the temperature.
Now, if you
First try.
if you want this, we'll post it as a 3MF in our Discord. And if you want to join the Discord, if you haven't already, it's linked in the description below. Yeah, why don't we upload the 3MF right now?
Yeah, why not?
I mean,
you want to print it?
It's looking pretty awesome.
Yeah.
Although I'm pretty sure that's a 1mm line width. That looks really
pretty thick. Because we're doing it 120% on 0.8.
That is 1mm.
Yeah.
Okay. Well, let's save this. And so anyone that's using a 0.6mm nozzle
Or
or
0.8.
0.8 will,
Or even a 0.4 CHT could probably do it too, once that comes out.
So what is the print time on this again? So because this is a 0.6 and not a 0.8 nozzle, it's 22 hours and 45 minutes. If it was on one of our farm printers with the 0.8 nozzle, it would be, I think it was 22 hours and like 10 minutes.
I think we actually got down to 21.
21 hours?
Something like that, yeah.
Okay.
21 and a bit.
Yeah, you can see it here. So I'm just gonna export this as a 3MF. Call it quality. And this is for PLA this is for PLA.
Yeah.
All right. And then we can just throw that. We'll throw that into the Discord. Would my Ender 3 print at the same speed?
Whoops.
Maybe a little slower. Depends on your extruder. I mean, this is pretty similar to the production settings that we have.
Yeah, I think you could probably get away with it. I don't know if it would be good at during like infill, for example, because it's printing quite fast. But it's mainly just the extruder being on this one. It's a direct drive geared extruder, so it won't skip as easily. On the Ender, you might get that like clunk clunk.
Oh, Robert was asking whether to look at 0.6 or 0.8 nozzles for his Prusa.
Oh yes.
I'd say it depends on what you're printing. 0.6 is a really good compromise because you can push it to 0.8 line width. And 0.6 still looks great, so it's gonna.
Yeah, I think if you want a very safe upgrade, 0.6 is what I think most printers should come with by default, honestly.
Ben's saying we need to print one of the shelf modules for that Benchy.
We need to print a really big benchy shelf. Actually, we have it right.
We have the really, I don't think it will fit in that one.
I don't think we'll be fitting. Oh, yeah.
Oh wait, let me switch to the main cam.
Look at that. I don't think our benchy that we're printing right now will fit into one of these cubes.
No. So you're saying we have to print a big one on the CR-10. Oh, we
Yeah.
should queue one up.
Cube a huge
That'd be
singular
a good
box.
release test, actually, because it would
Oh,
fill the
we could.
entire print surface.
We should do that. Yeah. Print a 300 by 300 millimeter plate. That would actually be a really nice demo because I don't think we've ever actually tried it.
No, the biggest we did was 200 by 2 or 220 by 220 plate.
Yeah.
That's on our website.
This is actually the first print we've done on this bed as well.
Yes. Set it. We actually just.
We haven't printed on a vapor on a CR10 yet. This is like first ever live on stream. We don't feel like testing stuff beforehand sometimes.
No, we got messed up by supply and shipping and stuff.
Yeah.
But we've got them on hand. We're testing them, and they'll be shipping to you very soon if you're part of the CR10 or the Sidewinder X1 beta.
Yeah. So we're actually
X2 beta 2, right?
Yeah, we're actually like putting kits together at this point. So the time when we said kits would ship out is looking like mid-November. If you're lucky, it might be a little bit before that, but mid-November is sort of
We're on
the
track.
time, and it's looking like we're on track for that. So, yeah, if you guys have a beta kit on order, stay tuned because it's coming, and yeah, it'll be really cool to see the feedback that you guys have for us because, you know, we're only able to test right now like the CR10 V3, but we want to see like, is there any difference on the V2 or S or the original, like the very OG CR10. I think someone in chat said they have a super OG old CR10. There's also the whole Pro CR10 Pro V2. So many different
There's so many.
combinations.
I wish they would just have one version.
Yeah.
So Ben's upgraded his Ender 3s with the Chimera, which is an interesting upgrade. I guess I'd be curious, you know, what are the main benefits you've seen to that? Because yeah, I guess on our farm we're running pretty stock, other than the hot end and the cooling setup for the hot end is custom.
Well, if it's a Chimera, that would be probably direct drive. So I'm guessing flexibles are on the table now.
Right. And just faster. Although
I would say higher extrusion rate.
yeah, maybe not faster because of the weight.
Yeah.
Yeah, I'd be curious to know. Go back to
Yeah, actually, Johnny says when he looks up videos on upgrading his Ender, it's usually just printed parts. Which actually, there are some good prints that you can do to upgrade your Ender or other printer. And I think a lot of them are pretty good, but some of them also just do nothing. Depends on what you want. I know some people put like really cool things on their extruder, for example, that spin around and look really cool.
yeah, I think that's I don't know why that gets included in upgrade lists a lot, but doesn't really do too much for you.
It's so they can say there's 35 different things to upgrade your Ender with.
Right. Okay, Ben's saying it's for TPU at 60 millimeters per second, which
That's
makes
cool.
makes sense.
Yeah, I've never printed TPU that fast.
I've
60 is twice what I can do.
Oh yeah.
Oh yeah, let's talk about that.
Yeah, I guess we're kind of wrapped up here. So make sure to join the Discord for two reasons. One is we'll be putting the 3MF that we made together. And the other reason is if you're not in our Discord or not signed up for our mailing list, I'd highly recommend you do, because we're putting together an event on the 24th. It'll be a really interactive video conference, basically a call where we get all the community members together to discuss how automation is the future of 3D printing and what that future should look like. So those of you who are around a couple months ago who helped out with the UI, we're basically building on that in the sense that we'll be taking community feedback on how automation should work in the future, what kind of features should be implemented into Quinly. We'll be looking at, things and features near and far, what printers make sense to support, and, integrations. For example, someone kind of mentioned earlier, we'll be talking about things like Clipper integration, whether that makes sense for automation. Yeah, it's basically going to be a really big group call of everyone that's interested in automation, everyone who's kind of a super user to voice their opinion and help us shape Quinly and the future of 3D printing automation together. So I'm really excited about that. We'll be posting updates to, by email or in our Discord. And yeah, we'll be doing it in actually, although I don't know if we should say the structure yet, but it'll be very, very interactive. Like you'll be able to talk in the group.
So more than a live stream.
Yeah.
If you don't want to just chat message, you could,
It'll actually be closer to like a call.
Yeah. A video call conference.
Kind of like
You can turn your video on if you want.
brainstorming session.
Yeah.
Essentially.
So the feedback we get during this will shape what we do. So if you have any opinions on that, I think it'd be really cool to get your, to see if you could join this. And also we're trying to actually build the future of 3D printing automation here too. So getting your ideas and feedback on sort of what like software features we want, and I guess any other considerations that maybe we're not even talking about yet.
Yeah, things like for those of you who are running Etsy stores, integration with Etsy, integration with e-commerce, like how much of a priority is that to you? How would that look like? Like what would an order flow look like? Like all that sort of fun feature-focused stuff. We'll be talking about a roadmap, and you guys will be able to have input on that roadmap as well. So it'll be pretty.
It'll be like Zoom.
Yeah, like Zoom, like a big Zoom call.
Was it Thanksgiving? Did we schedule it for Thanksgiving?
Yeah, we should check that we aren't colliding with.
We have Canadian Thanksgiving.
That was
we had it already
weeks ago. John's excited. Yes. Yeah, I think it'll be really fun actually. It was we kind of did a mini version of that when we designed the new UI, which was like interviewing actual users to see what features they want the most. And that's how we got things like where you can create a folder full of parts.
We created a folder with a
No,
slash in it.
Can't put this.
Linux doesn't like that.
Yeah, when you put a folder, that's how we got things like this, where you've got folders, but then you can also select a folder and send the whole folder to your print queue. Those are the kinds of things that come out of these types of sessions. And so we're, really excited to do that again.
So it turns out we might not be having it on the 24th. So stay tuned.
Yeah, that's why
because we just learned it's on Thanksgiving.
That's why you have to sign up. That's why you have to sign up, because you might find out it's on a different date. Yeah, but I think we're kind of done for today. If you want to continue the discussion, join us on Discord. We'll be putting the 3MF there. Make sure to leave a like on the video because it really, really helps get the word out. And I think there's a lot of useful information in here and in chat for people to learn how to better optimize your 3D printers and to learn about 3D printer automation. And yeah, it's oh cool. Okay, so John's saying that's how he set up his new UI. He's set up a folder for each different color, which is a very smart way of doing it. Because then you
That's
don't
good.
have to worry about color specific cheat code.
Yeah,
Yeah,
and that's good. You can filter it so you don't have all your other colors clogging up your view.
Yeah,
That's a nice idea.
awesome. Well, yeah, thanks everyone for joining us. Thanks for participating in chat and lending your insights. I think that made the stream way all the better and made our our Kira profile really good too. So yeah, I guess we'll see you guys in the next one.
Yeah,
any-
you can continue any conversations on Discord, guys. If you're in the chat and you're not in Discord, join it because you can interact with all these cool people on the chat as well as us. We always monitor the Discord.
Oh, and if you still want to get into the beta for the CR-10 Quinly, you can do that through our website by signing up for the beta program, and you'll get an email asking you what printers you have, or you can send an email to info@3dq.com. If you've got a Sidewinder, we'll set you up with the beta program, or if you see any other printers on there that are in beta and you want to try them out, yeah, just shoot us an email, sign up for the beta program on our shop page. Smack that like button. That's a critical step.
Yep.
Thank you, Kevin. And yeah, thanks for joining us. We'll see you all next time.
Bye, guys.
Bye.